Good day, and thank all of you on behalf of IISC, the Institute of Industrial and Systems Engineers, and our sponsor, the Poirier Group, for joining us today. We appreciate you taking time from busy schedules to participate in today's webinar. This is the second in a series of a mini series of 4 webinars that are focused on operational analytics. So looking forward to sharing some thoughts and experiences and frameworks and models and ways to think about how to do a better job of building better management systems, in particular operational analytics capabilities. So I'm going to go forward a little bit. For those of you that might not have participated in 101, I will cover off, just hit some highlights from that session, and then we'll move into what I consider to be 201 type of conversations. And then at the end, I'll segue into 301 and 401, tell you a little bit about what's ahead there. Just to remind you, the webinar is being recorded. There will be a copy of the recording and the presentation posted on the IISC website. You'll get an email from Zoom tomorrow that'll have the links that will direct you to exactly where to go to get those objects if you're in a mind to do that. If as we go along, if you'll use the chat function, I'll be monitoring that, and I'll weave questions and comments and observations into to my presentation as we go along. I'm not going to dwell on this. Again, this is something that you'll have a copy of. This is my background, so I just wanted everybody to understand what's the foundation of knowledge and experience that I'm using to present this material to you. In previous sessions, we've been doing these webinars. We've done over 130 of them now over the last 4 years, and the real focus is on performance excellence, organizational excellence, operational excellence, and I would say that the underlying theme has been the integration of people, strategy, process, and technology, and how industrial and systems engineering plays a role in the ongoing efforts to better integrate those 4 components in organizational systems. The reason that I got into measurement way back when I started my career at Eastman Kodak and then in graduate school at Ohio State was because I liked measurement, but I also felt it was so important to strategy execution. It's really the central nervous system and brain behind the integration of people's strategy, process, and technology. And as you all know, analytics and the analytics role is a rapidly growing and critical to success function in all organizations' pursuit of performance excellence. And it is becoming a major theme, a major component of many of the industrial and systems engineering departments around the country and the world. So in 101, the focus was on what I would say management systems engineering, in particular a framework that I borrowed from Harold Kerstedt at Virginia Tech when I joined the department there in the mid 80s, called the management systems model. And so I'll talk more about that and give you a little bit of an overview of that. So the one thing I'll say is that the approach that I'm taking to helping you understand operational analytics, whether it be a macro view of analytics or a micro view of how we create SQL servers and hypercubes and set Power BI on top of that, and then generate charts on top of that. So we're going to zoom in and zoom out on this conversation, as I think you all suspect when it comes to something like analytics. But the purpose of management systems engineering is to create, architect, engineer, implement, deploy, improve B systems, and I'm going to explain what I mean by B in just a second, that drive and enable process and performance improvement better and faster. And so my point in an article we wrote a number of months ago in the ISC magazine is that in the new roaring 20s, if you will, it's not whether you're getting better, it's how fast you're getting better. And so speed doesn't kill in this situation. Speed in fact saves. So when I talk about B, I've shared this model in previous webinars, but I'll go over it very quickly right now. It's just a simple model that says we spend our time doing three things in organizations. We administer or perform the role that we're in. In other words, we administer the business, we administer our job. And then we cater to crises. So we fight fires. We do things that are unexpected, oftentimes seemingly urgent. And then we do D. We do the dumb. We have a lot of non-value add, a lot of waste in most organizations. And then the B that I spoke about a minute ago is we build a business. In other words, we've got business process improvement, we've got operational excellence programs, we've got plan, do, study, adjust, and so forth. So tons of different banners under which improving what we do and how we do it is positioned in organizations. And so commonly in the current state, the B efforts, B work, B budget gets squeezed out by C and D. So the fighting the fires and the doing the dumb chews up a lot of time that takes away from our ability to spend time improving what we do and how we do it. There is oftentimes low maturity and capability and competence to do systematic B. So people are trained to do A, they're not necessarily trained to do B. And so that's why positioning industrial and systems engineering as an example in organizations is so important, because ISEs in fact are trained to do B. That's what our discipline is all about. Many organizations, the A is teetering on the brink, high variation in process capabilities. We'll talk a little bit about healthcare today. I mean, it's not almost no organization you go into today, whether it's a grocery store or healthcare, an emergency room, whatever, that you don't see evidence of the fact that there's a lot of variation in process performance. And at times it almost looks like it's on the brink of disaster. And the B portfolio, in other words, the things that organizations are focused on is not rationalized, it's ad hoc, and hence impact is suboptimized. So the desired state, as a result of doing the things that I'm going to talk about today, and then we'll talk about in 301 and 401, it's going to change those four bullets. So you're going to go from the bullets on the left to the bullets on the right. And so that's really the sort of simplistic, high-level view of what this mini-series is all about. Now, the purpose of operational analytics is to do these things in this order: facilitate and enable the creation of solutions that catalyze and enable better decisions faster, and then drive actions, improvement, implementation faster, and then drive benefits realization faster. Those are the desired and positive outcomes we want from the focus of our B work, and then grow enterprise value, system, process, business value, grow enterprise value. And we'll talk about what I mean by enterprise value. So the management systems model that I reviewed with you back in the first webinar, and by the way, if you didn't participate in 101, you can still access it on the ISC website. So 101 will be there in the operational analytics folder, and then 201 is going to sit right on top of that. So they'll be juxtapositioned with one another in the files, the folder there. So the model is that we've got what's being managed at the bottom. So we've got essentially upstream systems. Think of it as a SIPOC. So suppliers, input, process, output, customers, and who's managing, who's leading, who's accountable for the performance of that unit, that system. And then on the right-hand side, upper right-hand side, is what are the people that are accountable for the performance of, quote, the unit we're focusing on? What are they using? How are they making decisions? How are they using data and facts to support improvement decisions, the decisions and actions? So we basically walked around this model starting at in the lower center, the lower third of the slide, and we just went sort of clockwise around and talked about what's happening in management systems engineering, management systems analysis. So at the bottom of the slide, I said it could be the focus of our B efforts could be, we could be looking at the extended enterprise. We could be working on an organizational transformation. We have a number of members from UPS that have been in the Council on Industrial Systems Engineers, and they're industrial engineers, and they were promoted into a position where they were literally re-engineering certain major systems for UPS. So they had an extended enterprise view. It might be an organizational unit. So it might be a revenue generating business unit. It might be an enterprise shared service function. Could be an extended value stream. So it could be the supply chain, for example, extended to upstream, extended to include the suppliers, downstream, the stores, and the end customers. So the management systems model is robust in the sense that it can be used regardless of the unit of analysis. It can be a big system, it can be a little system. And so as we begin to approach management systems analysis, there's a number of fundamental questions that we have to ask ourselves. So fundamentally, it's how does it work? So we have to understand as B personnel, as people who are working on business process improvement, we have to understand first and foremost, how does this thing work? You know, what's its purpose? What's its function? What's its role? How does it work? Second, how is it performing? How has it historically performed? And then the follow-on question to how is it performing is, where are the failure modes? Where is it underperforming? And so that's where value stream mapping, failure mode effect analysis, all those kinds of tools that help us diagnose value stream performance come into play. And then if we were following, for example, the DMAIC methodology, define, measure, analyze, improve, control, the sort of Lean Sigma roadmap, then so we would do measure, then we would do analyze. In the analyze stage, we're figuring out why is the process underperforming. And so then we would migrate from the analyze stage to the improve stage, and we would be identifying on the basis of the RPN scores on a failure modes, for example, just to use an example of a tool, the things with failure modes with the highest RPN scores would be the things we would gang tackle. We'd go after them, and then we would create countermeasures, and then we would evaluate and track the performance of the process in relationship to the failure mode improvement work that we were doing to confirm and validate that, in fact, the countermeasures were working. And ultimately, then we would be evaluating to see whether or not this portfolio of B projects was, in fact, creating improved enterprise value. So there's a roadmap for management systems engineering and operational analytics, very similar to the roadmap that we see for Lean Sigma or design for Lean Sigma. And I don't think that the roadmap for management systems engineering is not as transparent, it's not as visible, it's not as well understood as the roadmap for Lean Sigma is. And so that's one of the reasons that we're doing this mini-series. So again, when you're in the early stages, when you're trying to understand how does something work, there's tons of things that you can do, tons of tools that you can pull out of your toolkit, so to speak. We can do SIPOC, we can do IDEF, we can do end-to-end value stream mapping, we can do business process breakdown structure. We can observe and walk the process and do structured interviews. So, you know, there's 3 ways to get data: ask, observe, and system documentation. And whenever we're doing the improvement of a management system, the improvement of a process, you want to invoke all three of those ways of getting data. So you don't just want to rely on system documentation. You want to also add to that, augment system documentation. You want to augment that with observations and interviews. And so, like I said, there's lots of different units of analysis. This is something that we did from our business process management BPM 4.0 and 5.0 webinar. But this is a very, very big picture of the shared service support infrastructure for an organization. So really big system view. And then we can zoom in. We can zoom in to AP, procure to pay. And so that's the concept of portfolio creation, is understanding how to map the business processes, whether it be micro or macro. So we do layered business process mapping. And then we essentially identify where are the pain points, where are the failure modes, and prioritize those. And then we can zoom in and we can go in and we can fix those pain points and systematically over time improve flow, reduce waste, reduce crises that we have to cater to in the processes. Another example, we can take the roof off a hospital and we can sort of from a systems flow perspective, we can look at the way things flow in a hospital. We did a great project, Capstone Senior Design Project at University Hospital East in Columbus, where we looked at from emergency room to patients being released out the back end of the hospital, and mapped it out, had a big flow workshop, got everybody end to end in a room, put it on butcher block paper, mapped out how things are flowing, where the pain points are, where the critical alignment points were that weren't being managed. It was a great process. So this is all part, again, of understanding how things work. And then, you could be zooming in, you could be in a Kroger saltine cracker line, and this is just a line that makes, again, saltine crackers. So on the front end, you got the stuff, the dough coming in, and on the back end, you got the crackers going out, and you've got spots, you've got control points along the way where waste is being created. And so the whole concept of control points, I think, is easy to understand if we're looking at a saltine cracker line, but you can look at control points in this hospital example too. Where are the critical alignment points? Where are the spots where we should be collecting data, should be measuring performance, should be evaluating performance? So the concept of whether we're working at a value stream level inside a bakery, for example, or inside a factory, or whether we're looking at something that's more transactional and less sequentially interdependent. So notice that this is sequential interdependence. Step one, then step two, then step three. In a hospital, you have sequential interdependence, but you also have goes here, and then it could go multiple different directions. So things could go a lot of different directions. So there's much more complexity in a hospital setting, in a healthcare system, than you tend to see in a bakery, for example. So then once we've done a good job of understanding what is the process I'm working to improve and how do I improve it, how does it work, and where is it breaking down, then the question that we can move to is we can start to better understand the people that are accountable for that process or system. What are the things that, what are the decisions and actions? What are the adjustments? What are the things that they don't know that they would like to know, that they think, if I knew this, if I had this information, it would help me make more timely adjustments to the process. It would help me anticipate where things need to be improved, where we need to tweak things. So the next step in the process is really use case. It's understanding the use case and understanding the stakeholders and pulling out of them things like what questions do you have that you can't or aren't easily answering? What are their obstacles to improving things? How do they want to see things? Meaning, how do you like to have data and facts portrayed? What is the right periodicity on study adjust? So should we be looking at data on an hourly basis, on a daily basis, a weekly basis, a monthly basis? So periodicity is a big deal because that's the time stamping thing when we're building the data model in a database. What are their information requirements? What do they need to know in order to do their jobs? What are the things that if they better understood would help them take the system to another level of performance? And how do they view the control points? Many times people that own a system, it could be a production line, a salting cracker line, whatever, a unit in a hospital. If you ask them, where are the control points? Where should we be collecting data? Where are the spots where we can make adjustments that will make a difference in terms of how the process performs? They'll identify more control points than exist in the system's data capture process. So when people set up ERP systems, for example, they'll go in and they'll say, okay, we got this line that's going to make this. Here is where we're going to capture data. And what we find, for example, in many organizations, we look at the process and we find 11 control points. They're only capturing data at 3. So the data capture design, so to speak, has been underthought and is underinvested in, and as a result, we don't have as much data as we need to, in fact, manage the performance of the process or value stream that we're working on. So once I have a good understanding of the leadership team, upper left-hand corner, and I've got a better understanding of what their information requirements are, and I've sort of codified those information requirements, so I know what they want to see, then I can move over to the data capture interface. I can go over and I can say, so in order for them to see these charts, to see this information, to have these questions answered, I'm going to need this data, these data. And so now we move over to the data capture to data entry step or phase of the management systems model. So fundamentally, this is the data management role in operational analytics. You have to systematically think through what data you need to provide what data you need in order to provide the information required for the leaders, the owners of the system that you're working to improve. And so we went over last week, in addition to the management systems model, which I just sort of walked through with you very quickly, we added in what I call the operational analytics triangle model, which I've borrowed with permission from the Intel Global Supply Chain Management Group out in Phoenix. And so like with the management systems model, where the objective is to convert management systems engineering into a roadmap that is easy for people to follow. Like DMAIC has grown to be something that's pretty easy for people to follow. It's a pretty well-defined roadmap for process improvement. So the same thing can be true for operational analytics. And what we've done is we've taken this triangle and we said, first of all, there's a set of questions. There's an information need that managers and leaders have as it relates to the job of continually improving the processes and systems that they're accountable for. And so that's what the question at the bottom of the triangle means. So everything starts with the fundamental questions that we need to answer so that the leaders and managers can make the right adjustments in a timely fashion that cause the system or process to perform the way it needs or is required to perform. So there's a foundational data role, which is below that blue line, everything that's below that blue line. And then there's what we call above the line, the analyst role, which is the conversion of the data into information and knowledge, and ultimately into visualizations, portrayals that provoke, that spark insights, that drive insights, that create what we call aha moments. So just to burst out the foundational data role, and then I'm going to drill down a little bit. So again, you'll have access to this and you can study this in a little more detail. But primarily one of the big challenges that we face in the data management role is that oftentimes, especially if the system or process that we're working to improve is of any size or scope, the data that we need to provide the information necessary for the people that are accountable for the system performance is oftentimes it's exploded. It's in a lot of different places. So we've got disconnected, even if we have an ERP system, we still have disconnected silos of data throughout the organization. And I'm sure that many of you have experienced this. And so the challenge with operational analytics is how do we move from what can be big data in a lot of disconnected silos to a very tight data model, hypercube relational database that makes it easy for us to sit an analytics app on top of it and slice and dice the data in a way that creates visualizations that are useful, meaningful, and again, catalyze or provoke timely adjustments to systems and processes to keep them performing and to keep them performing in a better way over time. So I like this picture because I think it's conceptually, abstractly represents what we're really doing in operational analytics. Over on the right-hand side is the data management role is one of figuring out what are all the sources of data that I need in order to enable this group of leaders and managers that are accountable for some business unit or some hospital or some production line or whatever to do their job better. And so what we're basically doing, and I know this is a very busy slide, but I think it's fairly easy for you to get that what I'm basically doing in the management systems model is I'm just taking the operational analytics triangle and I'm laying it on top of this management systems model. So all these data capture, those are all those blue explosions, those are all the control points where we're capturing data across the entire value stream, getting the data organized and stored and cleansed and integrated so that I can then begin to do the analyst work, feature extraction, knowledge extraction, visualizations. In other words, get to a point where I'm actually portraying information that again rounds the corner. So that red arrow comes around the corner. So pay dirt in the management systems model and operational analytics is creating a system of data capture and data to information conversion and portrayal that enables and provokes, again, timely decisions and actions that are aimed at ensuring that the process performs, that the process capability meets the spec limits, the requirements, the voice of the customer, the requirements of the customer. So I know that's there's a lot there, and I know that that's complex, but that really is the essence of what we talked about last week. So this is, I borrowed this from, again, Intel, and I've tailored it a little bit, but so to be able to be good at the triangle, to be able to be good at the bottom half, the challenge that we face is that in most big organizations, the bottom half, below the line, below the blue line, and I'm going to overstate this a little bit, but think of it as below the blue line, you got the IT department, and they sort of do that. And then above the line, there's really a role gap. There's a role definition gap. So in an organization we recently worked with, a retail organization. We were working directly with the users of the information coming from their ERP system and Power BI and SharePoint, and we were working with IT. And what we found was that the IT people were really good at the data management role. They really knew their stuff. But when you got them into Power BI and you started to get them into the knowledge extraction and the visualizations that provoke timely decisions and actions, it wasn't their skill set, and they weren't natural at it. And so I think a lot of organizations are in that same situation. And so that's why I think this list of things, good analytics comes from good context understanding. What I mean by that is good understanding of the strategic context. What is the organization strategically? What is the organization attempting to accomplish? And how does that, as contextually, how does that impact what I'm doing in my unit within the organization? Would be an example of the point. Teaching people how to be good with the bottom half of the analytics triangle is actually simple compared to teaching people how to be good at the top half of the triangle. In other words, be good analysts. Generally speaking, analytics is a slow craft development process for most people. And so picking the right people to be on your analyst team, to be on the team that is actually going to be developing the chart books, the charts, the information, understanding user requirements, understanding the use cases. If you pick the right people, then they'll be quicker at developing their competency at doing this. If you invest in the bottom half of the triangle, investment in the right data foundation has a huge positive ROI. And so what we need to do in organizations is get our analysts working more closely with the IT department to make sure that the data models that are being built are not just built by CIS minds, CIS type people, but are really built by CIS people working hand in hand with industrial and systems engineers to make sure that the data model supports all of the information requirements that the businesses and business units require. And then good data visualizations can tell the right story quickly because people are predisposed to believe what they see and can quickly grasp. So the hardest thing I had to do when I was at Ohio State from 07 to 20, teaching young industrial and systems engineers was how to create great visualizations. It's not something that, they don't teach engineering graphics anymore in most engineering programs. I don't know, it's gone by the wayside. And so the students don't really ever get exposed to how do you create great charts and graphs and so forth. And they're not exposed to sort of Deming thinking around statistical process control and how do you create good run charts and control charts and so forth. And then the next to last bullet, there's a very positive ROI that comes from getting operational analytics well designed and developed. Small analytics teams can wield disproportionate influence on the bottom line. So, having a BPI team, a business process improvement team, or an OpEx organization that has a small tiger team analytics group, what Intel found was huge benefits for our organization in the global supply chain operation. And then finally, good operational analytics provokes more timely decisions and actions, which drives improvement, which drives benefits realization, which drives enterprise value. So the way to think about that is that we're essentially, in fact, this is a slide that was created by one of the organizations I worked with a year and a half ago. The COO said, well, what if we just turned that triangle upside down and we said, visualizations are all about helping me gain new insights, gain understanding of what's happening and why it's happening. And then based on that, drives me into, makes me more confident with the decisions and actions I've got, which then makes me more decisive, which then drives results and benefits realization. So I like the slide because I think it, again, reinforces the point that the visualization piece is critical. And I've got a slide that'll speak to that in just a second. Check to see if I can get to it real quick. Yeah, this is the one I want to talk about. So it's sort of like this. It's, we've got data. The bottom half of the triangle is we've got data. Now somebody's got to figure out what data do we need. So you've got to decide what Lego blocks are you going to put in your pile. And then we're going to organize the data, cleanse the data so that it can be sliced and diced. It can be sorted, it can be arranged. And so what we want to do, and a lot of times that's where it sort of ends. If you look at a lot of the war stories about Power BI implementation, one of the things that people are finding is that the IT department gets this new tool called Power BI, and then they go out to the user community and they say, you can generate reports. And so all of a sudden there's this, they get inundated with this call for, give me this report and give me this report. And the reports are primarily around arranging the data so that they can see what they had in an Excel spreadsheet, but they can slice it and dice it and see it sliced and diced different ways. And so all of a sudden, you've got the IT department's got this huge backlog of report requests, and everybody's sitting out there and they get these reports, and the COO of the company I was working with, he said, I got these reports, and he said, I'm data rich in information poor. I'm swimming in a sea of data. I don't know what to do with it. So you got to migrate from that situation to the one on the right. And the secret is you got to explain it with a story. So you got to put the Lego blocks together. And the story is a metaphor for what business results am I trying to create? Measure what matters, portray what matters, and then use that to drive decisions and actions adjustments. And so what we want to do is we want to take the data to the next step. So we want to take the data to the next step, which is what we talked about here. And we want to make sure that the data portrayal is not just feature extraction. It's not just Excel spreadsheets with filters on steroids. It's actually us portraying the information in a way that people see things they didn't see before. They have insights and understanding that they didn't have before. So it's all about, again, this interface between understanding what leadership and management wants and needs to do their job, translating that into information requirements and how it can be portrayed in a way that makes it easy for them to understand, and then swinging back down to making sure that the data model supports the information requirements. And all of this, again, is aimed at speeding up. So ultimately, operational analytics is and management systems engineering is aimed at reducing or minimizing the latencies. So latency, what I mean by latency is there's a latency in terms of capturing the data. Then there's a latency. Then takes time to analyze the data. Then it takes time to make a decision. Then it takes time to act on the decision, to implement. Then it takes time to evaluate benefits realization. Similarly, in the operational analytics triangle, data selection takes time, data gathering takes time, storage takes time, integration takes time, cleansing takes time. So the job of industrial and systems engineers is to work on these processes associated with figuring out what to capture, figuring out what to analyze and how to analyze it, figuring out how to support faster decision-making, better decision-making. It's really our job to improve that process. That's the essence of management systems engineering. So today, what we see again, and I've got a bunch of slides here that just build off the same thing. Most organizations, many, not all, but most are, you say you've got a picture, you've got an infrastructure or an architecture that looks something like this. And over here, you've got dashboards and reports. And so again, I'm just going to run through a bunch of these, just different views of sort of the architecture of the analytics triangle, so to speak, from top to bottom. And so what I've really been focusing on in terms of what I've been saying, sharing with you, is that the pay dirt, the essence, the secret to success is up here where you see reports and dashboards. What we find is that because the analysts, because there aren't many skilled analysts out there, so if you go into a lot of the analytics MBA master's programs, you'll see that a lot of the work, a lot of the emphasis is on bottom half of the triangle, the data management role, and maybe some on feature extraction. So again, I think that the secret to being successful with operational analytics is this business intelligent analyst decision support role. So, data scientists have to have these roles, and this one here, communicating and visualization, is probably the role in this slide, at least. That's the role that I think we're struggling the most with, which is why I threw in Nancy Duarte's book, Resonate and Data Story, because I think her work focuses on developing methods for doing a better job with communicating and visualization. And so if you walk through the top 3 layers of the analytics triangle, we've got feature extraction. So feature extraction is a selection of data elements of interest. So it's what are the dials that you'd like to see? What are the key performance indicators, the measures of interest? What are the use cases and the user requirements? And so a report in Power BI, many of you are probably familiar with what a report looks like in Power BI. That would be what I would call an example of feature extraction. So it's the first layer, it's the first step in migrating from data to information. It's essentially a database portrayal with the ability to slice and dice, sort, filter, organize. Yeah, so we got some, so the title of the book that I referenced was Resonate and Data Story by Nancy Duarte. And then Ferdinand shared, he used Simple Says More approach in Power BI. So yeah, I'm going to look that up, Ferdinand. Thanks for sharing that with the group. So common issues that people are having with feature extraction in Power BI is report proliferation. They end up getting data rich and information poor, and they get stuck with feature extraction. So knowledge extraction then is the conversion of the data portrayal to information portrayal. The basic distinction is that information is directly usable. So when you look at the portrayal of knowledge, when you look at the portrayal, you know the point. I mean, that's the simple way of saying it. You know the point. So I look at something, somebody presents some data, and I look at it and say, I get it. I know what this means. I understand what this means. I may not necessarily not understand what to do about it, but I get what it means. I get the insight. So that's knowledge extraction. So then visualization, and I said science and art because I think it is a little bit of both, is all about how you portray the information so that knowledge produces results. It's the art of storytelling, persuasion. It's all about creating aha moments. So it's I get it and I know what to do, and I'm going to do it quick. So it's where the questions are put juxtaposition with the answers. and the decision makers get it. They know what to do next. So here's a few more books for you to think about. So Fifth Discipline Field Book, Measure What Matters by John Doerr, Influence and Persuasion, Good Strategy, Bad Strategy. That sort of gives you some context stuff. And then Pyramid Principle. Pyramid Principle by Barbara Minto is probably the Bible for a lot of consulting firms when they're teaching consultants how to create logical, clear, powerful presentations. So here's some simple examples. So this was that retail organization we worked with, and they were interested in, they had questions about sales. And so they had all this data, but nobody had ever converted the data into these kinds of charts. And so they said, have sales improved from 2020 to 2021? So I simply did a time series plot of sales by week. And I've highlighted the two periods of time of interest. And then I said, okay, well, what if I did an overlaid histogram? So then I did an overlaid histogram, the second chart. So notice that, I do get insights in the time series plot. I get a different way of portraying the insights with the overlaid histogram. And then I can do confirmatory data analysis. I can do hypothesis testing, and I can say, is there statistically a difference between 2020 and 2021? And the answer is yes, there is. So it comes out very definitive. It's confirmatory data analysis. So essentially, what analysts do is they're really, really good at exploratory data analysis, confirmatory data analysis, picking the right kinds of portrayals. And that takes, again, it's a craft, and it takes time to do that. I worked with Minitab for 13 years, teaching with it, using it on 250 projects with clients. And I wouldn't say I'm great at it, but I'm pretty good at it. And I think I've gotten much better at being able to play around with visualizations. You get a sense of which visualizations work and which visualizations no. Now, to make a point, so the organization we work with, they never had done this slide, never. But what they would do is they would go into Power BI. This is a table, this is a report in Power BI. And they would just, again, it was filtering. It was like Excel filtering on steroids. So this is the same data we were looking at on that chart before. And this is the way they were making decisions. It's like accounting, it's snapshot view of things. So you can draw sort of the same conclusions, but you've got to work harder at getting it. And your conclusions might be different than the conclusions that we got when we did it this way. So we can do the same thing for May through August. These are rational subgroups, right? So this is a rational subgroup of data. So that's a topic for another day. A lot of people would just analyze the whole data set. They'd put all the data in a data lake, in a pool of data, and they would just analyze it. But what we can see is that, December to April is different. Every year it's different. So that's what's called a rational subgroup. We've got to analyze the data by that rational subgroup. So the operational analytics specialist has to be able to, has to be able to peel the onion back, so to speak, and to be able to understand that we're fixing the process, not just fixing the problem. Make leaders and managers go to a different level of thinking about what's happening and why is it happening. So I'm going to skip through some of this. 301. So that's sort of my 201. It's a recap of 101 with a little more drilling down, a little more detail on the analytics triangle, in particular the top half of that triangle, the analyst role. So I feel good about the storyline with that for you. And now just want to give you a glimpse of what 301 is going to look like. So, you know, we could create better operational analytics. And if we don't, we could create great Power BI systems and put reports on SharePoint, and everybody would have more visibility to data and be able to slice and dice the data more easily. And not move the dials, not move some of the dials on enterprise value one bit. So what I want to talk about in 301 is what are some of the other system components that we've got to put along with Power BI as an example, in order to get things into the end zone. In other words, actually drive to the end game. And so, you know, we got to do things like we've got to interface with the planning system. So measure what matters. Can we maybe get into OKRs? So we start to develop OKRs for units. Can we do agile? Can we blend agile and OKRs together? And so what we really want to do, I want to do in 301 is have you think about the V system design process and talk about what are the components of a B system. So to this point, we've talked about the measurement, evaluation, analytics system. There's a planning system that's part of B. There's the deployment process that's part of B. There's technology enablement, which includes process design, that's part of B. There's the motivation front. How do we make sure that we're getting ideal behaviors for our employees? There's the communication and coordination front. How do we make sure that people are informed and that people are managing critical alignment points, managing interdependencies? And so then the darker green boxes represent examples of components that I'm going to talk about in 301. And so in 101, we sort of did define. So this is DCDOV. So we're designing a management system with a major subcomponent called operational analytics. 101 is really defining what we're talking about. So that's those bullets. That's what we covered off in the first webinar. 201 is peeling the onion back a little bit more on the things that we covered off: the management systems model, the operational analytics model, and what does the concept design really look like for a better management system with more solid operational analytics. And then detailed design and development is what we'll get into in 301. And then 401 is really reduction practice. It's the optimize, verify. So we've got a case study for you that we're going to do. So 401, and I know that 401 and 301 are out of order. It was a scheduling mix up on my part. So we've actually got 401 webinar happening just before the 301 does, but it won't make any difference, I don't think. So what we're going to do in 401 is bring in the person that runs Michael Cesar and one of his colleagues. He's the Chief Data and Analytics Officer for the University Health Network in Toronto. And I was exposed to them back in 2017 and very, very impressed with the work they're doing. And it really aligns to what I've shared with you in 101 and 201. And so this is a slide from their presentation. They're going to talk to you about their data and analytics strategy. They're going to talk about what is a data-driven organization, so you'll get a sense of that. And so I'm really excited about that. That's coming up the 14th of July. And then, as I mentioned, the Operational Analytics 301 session will be on the 18th of July. So those are out of sequence, but again, I don't think it's going to matter that much in terms of helping you understand the storyline. And then in August, the first week of August, there'll be a feature article that summarizes everything that we covered in these webinars in the ISE magazine. And then I want to let you know that in August and September, we're going to be starting an AI miniseries. It's going to be AI through the lens, through the view of integrated systems engineering. So we're gonna. I'm really excited about it. We're in the process of designing it right now. I'm lining up the panelists that are going to work with me on it, and then in September we'll have our annual Final Four Capstone Senior Design presentations. And so there's a question that came in. So 101 and 201 will be 101 and 201 will be posted on the IISE website. You're going to get an email from Zoom tomorrow, and in that email, thanking you for attending today, the link to get to the IISE website, specifically where the recording and presentations will be in that email, follow-up email tomorrow. So look for that to come through. So we've got about 5 minutes. Are there any other questions that you have? So Chris, one of the questions Chris had was, have you had success utilizing process mining systems to enhance the data capture mapping aspect of operational analytics? So Chris, I gather that what you mean by that is automated data capture. So like sort of concept like sensors. So we predefine what data we want to have captured, and then we figure out a way to automatically get that data and tell it where to go, put it in the right spot. Is that what you mean by that, Chris? Okay. Yeah. Yes, for sure, Chris. And I'm glad you brought that up, because we're also going to do an operational analytics 501 and 601. And the focus of 501 and 601 is going to be on advanced, what I would call advanced tools and methodologies. So Chris, in 501 and 601, we're going to actually get into that kind of conversation that you're talking about. Yeah, so we'll zoom in on that. That's a great question. Thank you. So if there, yeah, you're welcome. Thanks. Yeah, and Aniket, that's a good question. Is there a common list of courses, tools that would be helpful to learn? That, again, Aniket, is what I plan to cover off in 501, 601, is to provide you with those kinds of lists. Advice from people that do this all the time. And so we'll be doing that. So listen, I felt good about today. I thought I covered off what I felt was important to share with you. I hope that it was added value for you, that you enjoyed it. And I'll look forward to seeing you on the 14th of July. Thanks very much, and have a great rest of the week. Thank you.